Hi everyone. Let's start our talk about Telegram Open Network and how it can be improved and how Ethereum 2.0 can learn something from Telegram Open Network experience. My name is Nikita Kozlov and it's my colleague. His name is Kirill Kuznetsov. We want to talk about it, and let me first talk about our team. Actually, I am part of a big team of software engineers. We are like a group of hackers. There are about 6 of us, and actually we made several very important projects for Ethereum for the last couple of years. So actually our projects have, some of them have 150,000 users that have an Ethereum wallet. Also, our team members published about 5 articles on other research that have some like scientific value. Also, we are really like very big hackathon lovers, and we visited about 18 hackathons for the last couple of years. And most importantly, we visited most of the Ethereum global hackathons, like Ethereum Singapore, Cape Town. We were on ETHDenver last year, and actually we're trying to participate as much as hackathons as we can. And actually, on most of them, we were mentioned somehow, and on some of them, we won something. Especially, we won, like we got the main prize on ETH Boston with our latest project. It's actually zeropool.network. It's anonymous transactions on Ethereum. We use ZK-Snarks technology for that. If you heard something about Tornado Cash, it's pretty the same, but actually, we are not mixer. We allow users to make atomic swaps anonymously also. So check this out if you're interested in anonymity in Ethereum. So let's talk about Telegram Open Network right now. Actually, it's like a blockchain that was released a couple of months ago. It's a product of Telegram team, Telegram Messenger team, that is proof of stake. Also, what is it? Actually, it's the most interesting part about it is that it uses sharding approach to send transactions. So actually, Telegram is a proof of stake blockchain with sharding, and also they have smart contracts, and it's possible to communicate between shard chains using smart contracts only. So basically what they have right now, they have smart contracts with sharding approach, and also they have Ton virtual machine. They have their own virtual machine that they read together with 2 languages. They have fifth language and funk languages. So like it's how you can write smart contracts on this platform. And actually, they released only full node on C++ and light node on C++, and also small examples how you can read smart contracts without any documentation at all, without any like suitable information, anything that we can learn to develop something. And we need to, when we started to develop something on Ton, we need to learn it from scratch. We use source code to understand how this language works. So actually, they announced like a couple of months ago, like 2 months ago, they announced first contest. It's like international contest. It was like hackathon. It was a really big hackathon, and we spent about 3 weeks to participate in it, and we won the first prize in the most complex nomination with like implementation, the basic smart contracts for Telegram Open Network. So we have some experience, and right now we just want to share how it works and how this network works and how we can use it in Ethereum 2.0 in phase 5, for example, when we will start to think about how we need to design smart contracts with sharding on Ethereum. So, like the key points about Ton from technical point of view, what we need to know. Firstly, it's cells. What is cell? It's like basic storage unit, and everything in Telegram Open Networks, we store everything in cells. Like, cell is just something that have 128 bytes of any data that you can store, like 1023 bits of any data there, and also you can store up to 4 references to other cells that can also store another 4 references to another cells. And actually, it's like actors model how you can store data, and like you can reference this data between different cells. Like it's like everything in Ton basically is group of cells. They don't have any other primitives on the layer of storage. Also, you have messages between shard chains. So basically, in Telegram Open Network, they have pretty the same thing as beacon chain. It's called master chain, and they have a lot of like shard chains. They called it work chains. And actually, in Telegram Open Network, you can easily communicate between different work chains, and you have different options how you can communicate between work chains. The first one is without hypercube routing, so you don't need to pay a lot for calls, but your calls can be executed in unpredicted amount of time. and you can use hypercube routing to have like a fixed amount of time when it will be executed. So, also, it's very important to understand how you can create account at Ton. Like, for example, at Ethereum and at Bitcoin, we just have private key, we have address, and we just need to send money on this address. And actually, we are set up. We have account on the Bitcoin. Actually, on Telegram network, it's a bit different. What we need to create a smart contract. We need to compile this smart contract and deploy this smart contract to the network. After that, we need to send some grams to this account, to this smart contract, to this address, and after that, it will be activated. And only after that, you will have access to your funds. And basically, the main idea is that there is no any basic account on Telegram Open Network. If you want to have a wallet, you need to write smart contract, you need to implement it, and you will have it. You need to deploy it, and you will have this wallet. You can control this smart contract will control all your funds there. That's like the main points about Telegram Open Network in general. So, and right now my partner will talk more about how simple Telegram Open Network wallet looks like in fifth language and in fifth and funk languages.
Okay. Ton wallet, it's a smart contract that contains two main things. The first one, it's a sequence number. It's like a nonce in Ethereum that protects against double spending attack. And the second, it's a protection with a private key. You need to sign the external message hash by your private key and next verify the signature inside the contract by your public key that was set when contract was deployed. And the most important thing that you can customize your wallet inside the Ton blockchain. If you have the sequence number and signature verification, you can add any functionality. For example, it's multi-signature or asset transfers. And I want to explain how to work with the storage inside the Ton. The storage contains one cell with up to 4 references to another cells. And to get access to the specific memory area, you need to preload all bits or skip these bits before. And for example, if you want to get access to the old num area, you need to load the storage signal 32 bits. And to write to the storage, you need to build one cell with data, and even this data didn't change, you need to specify this data inside this chain as well. There are two functions that are available from outside of the contract. The first one is external function. The message provided to this function goes directly to the contract, and this function has one parameter, it's a slice with the message body. And second function, it's internal. The message provided to this function goes from another contract. And this function has 3 parameters. The first one is a message value. It's amount of grams provided to this contract. The second is a system cell with the flex and the source address. And the last parameter, it's a slice with the message body. Let's look how to communicate between the contracts. This is a scheme that explains how to communicate between 2 contracts. On the first step, we need to send the message from contract A to the contract B. Next, contract B will handle this message and send callback to the contract A. And contract A will handle this callback. Let's look at a simple implementation of the contract communication. To send message to the contract B, we need to build a cell that will contains of destination address. Also, we need to attach some amount of grams, almost for forwarding fee, and add message body. And next, this cell will forward to the send raw message function and goes to the contract A. The contract A will receive the message to the ref internal function and handle on the line 44. And next, send the callback to the contract B. And contract B can handle this callback by the operation code. You can choose the operation code to call the specific function that you want after the callback and handle this callback. Yeah.
So, like, actually, if you'll try to understand like what are the key features of Telegram Open Network and how they implemented smart contracts with shard chains, the main ideas that they use pretty simple approach. They decided to have a really low-level approach to develop smart contracts. Actually, they have a very simple stack-based virtual machine, and when you develop smart contracts, you need to communicate directly with this machine. Actually, you have access like to the low-level assembly, and most of the smart contracts that are right now deployed at Telegram Open Network, you can't deploy it without working with assembly. It's a bit difficult on the first time, but because of this approach, it's much more easier to implement sharding and to implement the ways how you can how you can communicate between smart contracts in different shard chains. And I think that it's very important point that if you want to somehow to make it work, and if you want to make sharded smart contracts on Ethereum like as fast as possible, we need to think about how we can go to the more low-level approach and how we can simplify the approach to develop smart contracts on the low level. Currently, I think it's a big problem on Ethereum, and it's like the way how we can fix it. Just looking at how Telegram Open Network implemented it. Secondly, like as I said, and actually the main idea that I think is very variable here is that they use actors model to communicate between shard chains, and each unit of data, each state is actually a combination of cells that actually I see it's like a graph, and because of that, actually it's much more easier to shard this blockchain on different nodes. So it's like I think the key feature of Telegram Open Network. The main problem that they have right now is lack of developers community, and it's obvious because they don't have a normal documentation and they don't have any like public communities that are really active right now. But basically they have a lot of engineered solutions that are really nice, and we can use them in Ethereum, for example. So also I want to explain some another features that right now are not very stable on Telegram Open Network, but it's really great and we can use them in Ethereum 2.0. The main problem that we have right now is that if we will have smart contracts with sharding, the main idea of shards is that you can't communicate with other shards, you can't like share data between them, and because of that it's much more scalable. Every node don't need to communicate with another shard, and because of that you can really scale like these shard chains. But it's the main problem for protocols like DAI. For example, we need to find a solution how we can send transactions between different different work chains, shard chains, and the only way how we can solve it is we need to have a common contract between them. And actually, for example, Telegram Open Network, they have a feature that you can actually deploy your smart contracts to all shard chains instantly. You need to pay a lot for it, but you will have your smart contract state will synchronize between all the shard chains, and it's like a solution how you can really implement some critical protocols tokens, for example, for the all shard chains, and you can communicate with them on the all shard chains, and it's like the point how you can solve this issue in Telegram Open Network. I think we can make something the same on Ethereum 2.0, and it's like a good idea that I think it can be used there. Actually, if you have any questions, you can ask it right now. I think it's the end of our talk. Like the main idea of this talk, as I said, was just to let's look at Telegram Open Network right now, because they have a lot of interesting things there that can be useful for approach on Ethereum 2.0. Like how we can scale it and how we can solve something with smart contracts. And like that's why actually we decided to look at Telegram Open Network and research something there, like what they have. Thank you.
you can use one private key for different contracts. And how to build the contract address. When you deploy your contract, you have the source code cell with the fifth assembler, and next it's initial state cell, and initial storage cell, and all these cells combined into one cell with their references, and we get the hash from this cell, and this hash will be the contract address.
So basically you don't have like a primitive an account in Ton. You just have a group of cells that somehow can be executed by Ton virtual machine, and you need to explain, like to show how a virtual machine needs to communicate with these cells. And each time when you need to send transaction, you need to provide a signature, and you need to implement signature check on the smart contract. And that's how you can build a wallet. Like you don't have account, and you don't have, and like the way how you send transactions is like on your own. You can use different approaches, not only, for example, private keys. So like you can use any approach how to send funds. You just have like a smart contract. It's like a group of cells, and there are some assets on this like on this smart contract. And the way how the smart contract will send these grams is only controlled by these functions there. And there is an option to check the signature. Like we have implemented like some precompiled features, like how you can check signature there, and because of that you can easily implement wallet, for example. But there is no any official wallet, and each time you need to create an account, you need to solve on your own and decide on your own how you can create this wallet. Like what do you need? You can actually create an account without any private, like checking any signatures, and these funds can be distributed by anyone who will make a call on this smart contract.
Can you send transactions with no signature?
Yes.
What about the resource management?
What do you mean?
So I'm wondering if you can swarm the network with no signatures, therefore no identity or nothing at stake. What's the risk that the network gets swarmed?
Actually, the main idea is that you have identity of any smart contract, because when you deploy it to the network, you will get an address on this network. And that's why how you can navigate and how you can send transactions to different smart contracts. But if you don't have private keys, it's like only issue of persons who will deploy the smart contracts, because anyone can just use these funds. Like they have a gas, and also they have a fee for that. And because of that, it's also like they have like a way how to manage amount of transactions on the network. It's more close to the blockchains like Stellar, where you need firstly to send some money on the account to activate it. It's pretty the same, but in our terms, we don't have an account at all. We need to create this account on our own. And each account is just our own custom smart contract. And actually everything in Ton is just group of smart contracts. That's all. Like that's the main idea, that it's very, very customizable, because you don't have a simple smart contract. You can use one private key to manage multiple addresses, multiple smart contracts on this network, and that's like the main point. It's a bit different approach that we have at Ethereum and Bitcoin, and it's very, I think it's like there are a lot of advantages and disadvantages of this approach, because it's not so user-friendly right now for most of the developers and for most of the users. But on the same side, it's very customizable, and we can create a lot of new features using this approach. Thank you.